As we conclude with our last discussion of the complex numbers, I would like to talk about roots and complex. So let's look at some models and make sure we have a clear understanding of that main objective. So roots and complex numbers, we have now defined by the square root of a, given that the positive number a, the square root of a is the positive real number, whose square is a, and then we also note that the square root of a negative a is defined by being I times the square root of a. So that is pretty much the principal square root that we are now going to distinguish between the negative square root of a and the negative I times the square root of a. So we're going to apply the various rules here and pay caution to the radical expressions and properties that we will look at as to how to multiply the square root of a times the square root of b, which then equal the square root of ab, and then it can be broken down as the square root of a over b, which then can be equal to the square root of a over b. So we're going to look at various scenarios that can assist us with this process. So if we look at the example here, the square root of -9 times the square root of -4. Right away, we know two negatives make a positive, so that result became the square root of 36, which is 6. But in the essence of having square root of 9 times the square root of -4, then what we have to identify is take the square root of -1, which becomes I, the square root of 9, which becomes 3. Likewise, the square root of -1 here, which becomes I, the square root of 4, which becomes 2. And then we will multiply 3 times 2 for 6, I times I for I squared. We would call I squared will be converted to -1. Therefore, -1 times 6 will become a -6. So in that rule and applying these properties, then we need to make sure that we understand the process when the various radicals are expressed accordingly. All right. So let's look at these two examples that we will walk through and make sure we understand the correct procedures to simplify these expressions, which are involving roots and complex numbers. Take a moment and jot that down, and let's begin the process. Okay, so our first step is for us to note that we need to express this and write this out twice. So let's write this out twice. And then let's begin the multiplying. Okay, so let's pause and let's work on completing the multiplication. All right, so once we expand and multiply this out, we can now see that here 2 times 2, 2 times negative times the square root of -3, here to the there. Then we did negative square root of -3 times 2 here. And then lastly, negative square root of -3, negative square root of -3 times, once again, negative square root of -3. Now, what we need to understand is that we already know that 2 times 2 will give us the result of 4. Okay, so we're good there. Now, with 2 times, now we realize that we got a negative, so we know the negative is coming out of that. And I'm working with the square root of -1, and then I'm working with the square root of 3. Okay, so the square root of -1 will be renamed I, and then I have the square root of 3. So that's the breakdown there. So -2I times the square root of 3. Once again, we do the same process. We know that we have 2 once again. I then have another negative. Once again, with the negative square root of 3, I work with the square root of -1, and then the square root of 3. And that allows the square root of -1 become an I. And then once again, the square root of 3. Okay. Simplifying negative negative square root of 3 times negative square root of negative 3. That's a mouthful. However, here we realize we have two negatives coming out. So those two negatives will turn that into a positive, okay? But then I need to understand I have the square root of negative 1 times the square root of 3. Once again, square root of negative 1 times the square root of 3. So in that position, that again allows me to know I have here, given in that process, that I will have the square root of 3 and negative 1. So let's multiply that out. Square root of 3 times the square root of 3 as a sidebar. We know that that would be squared. So square root of 3 times square root of 3 will become 3. Okay. And then I realize here that the square root of negative 1 square here, that will simply give us I square. And the I square from the square of negative 1, we know we have I times I. And I times I will simply become I square. And then that will be renamed negative 1. So here with a negative 1, so we now have negative 1 times 3. So that result will become a negative 3. So I will pull down 4, negative 2i times square root of 3, negative 2i times the square root of 3. That will combine to be minus 4i times the square root of 3. And then we will show minus 3. So now, last step, let's combine like terms. I will combine 4 minus 3 for 1 minus 4i times the square root of 3. Final answer. All right, in this process, let's look at model B, square root of 4 times over the square root of negative 4. And once again, I've already done the breakdown of the problem in the denominator, the square root of 4 over, we just pulled out the square root of negative 1 times the square root of 4. And here with the square root of 4, we automatically know that result will become 2. And then we also can identify that again, the square root of 4 is 2, and the square root of negative 1 will become I. So what I can do now is cancel like terms is my next procedure. So I will cancel out the 2's. So that leaves me with 1 over I. And here, that will go back to the special rule. And if we go back to our previous video, it was identified that when you have 1 over I, that it will also will be known as negative I. So when you have 1 over I, that can always be simplified to be negative I. And that's the final answer. So now, here are the solutions and steps that we exemplified here that you can pause and review again, and if you want to just practice the problem again, please do so. I encourage you to practice the problem a couple of times, 3, 4 times, to understand the procedures, because it's important that you understand the concept of the square root of -1 and the process of I in these conversions. This completes the conclusion of 1.5. Please feel free to contact me if needed. Take care. Bye now.